So this video is lesson 7.3, shapes of distributions, and we're going to start out with a little bit of a review. Now, if you notice, these graphs right here are histograms. They are not dot plots. So just take a second, pause the video, and answer questions A through D, and unpause when you're done, and let's see how you did. Okay, so the graphs show the distributions via histogram of the heights of 250 adult American males and 250 adult American females. So what does the y-axis represent? Well, if you look at it, you've got height in inches on the x-axis, but then you have the frequency on the y-axis. So it does represent the frequency, but what is frequency? It's basically how often something occurs. So it's going to be how many in each category. So for instance, if you wanted to figure out how many males were 75 inches tall, then you just follow to the top of this little bar right here, and it would be 8. So that's how you read a histogram. Okay, question B. Why do both graphs start at 55 inches and end at 85? So if you look, this one looks kind of symmetric, but this one's got a lot of empty space here. This one's also symmetric, but it's a lot of empty space. And the reason why they're on the same scale is so that you can compare both graphs. If they're not on the same scale, you're not able to compare them. It's very much like trying to compare something like 2/5 and 3/7. It's difficult to do that because they don't have the same scale or the same division. So you would need a common denominator to figure out which one was bigger or smaller. All right, question C, it says estimate the mean of each distribution. So on the male side, it looks like this is about the middle. So I would say about 70. And then over here on the female side, a little bit less than 65. So let's try 64. All right, which graph has a lesser standard deviation? Now, that is something from the beginning of chapter 7. So standard deviation is how spread out the data is. So if you look, the males start about here and here. The females start about here and then in here. One of them is a little bit smaller in range than the other one. You notice how there's not really a lot of variety here compared to this. Is a little bit more variability in the male. So that means that the one with the lesser standard deviation would be the female histogram. So both graphs are roughly symmetric. And the reason why they've got this little like curve here, it's to show like a normal distribution or a normal curve, and it's sometimes known as bell-shaped. So a histogram is very much like a dot plot, but a dot plot shows individual like values, but a histogram kind of groups them into categories. So you've got, you know, between like maybe 68 and 69 inches tall, or 70 and 71 inches tall. And it just kind of depends on your settings, on what your histogram looks like. And we are going to make some histograms a little bit later on, and I'm going to show you what it means to change the settings, and you'll see how it changes your histogram. So let's talk about the shapes of different types of histograms. So in the last lesson, we talked about shapes of box and whisker plots, but now we're going to look at a histogram. So the one that's pretty obvious, the one that we just talked about, would be the symmetric one. And the reason why it's symmetric, if you split it down the middle, the left and the right look like you could fold it on that dotted line, and then they would match up. The next one we're going to talk about is uniform. Uniform, and remember, real world data is very, very rarely perfect, so it should be close to the shape, hardly ever going to be exactly that shape. So a uniform distribution has that kind of rectangular shape. All of them are going to be about the same size. And then you have what we talked about yesterday. We have skewed left and we have skewed right. Instead of having a whisker over here, we have something that we call a tail. Same thing over here. So just like it was named for the long whisker, it's named for that long tail. So if you have a long tail on the left, it's called skewed left. Long tail on the right, it is called skewed right. So a big part of the lesson is not only being able to describe the shapes, is that we need to actually choose appropriate measures. This is actually really important. It is not in your textbook. Your textbook actually has something similar to this. It's just not as like detailed. So this is out of the statistics text that I have. So basically what you need to understand, and I briefly touched on it when we were talking about box and whisker plots, but if you have a tail over here on the right hand side, you've got an outlier that is pulling this data to the right. So what you need to do is you need to think that all of your numbers are getting like stretched over to this direction. Well, what happens is it has a big effect on the mean. So whenever you have an outlier, never use the mean to describe the data. You want to use the median. So if you have skewed data, make sure that you use the median. Okay. Now, if you look at the other side, so I've got a tail over here. It's pulling the data because of this outlier. I've got a really small number compared to the rest of my data. It's pulling to the left. And if you notice, see what happens to the mean? It's also pulled to the left. So once again, we do not want to use the mean for this. We want to use the median because it is less affected. Now let's look at symmetric data. So symmetric data will typically have a mean, median, and mode that are approximately the same values. They don't have to be exactly the same. That's why we use this symbol right here for approximately. And it's appropriate for you to use the mean in this case because it is not affected. You can actually look at data and see which one would be the most appropriate. If you know that the median is pretty far away from the mean, then it's going to be skewed. If the mean is actually greater than the median, so let's say the median is 80 and your mean is 85, you can tell that that mean has been pulled to the right. Likewise over here, if your median is 80 and your mean is smaller, then you can tell it's being pulled to the left. So just by looking at the statistics for the data, you can tell what the shape is going to be. Okay, so if you flip it over on the back, I've got it kind of written in words what you need to use. So if you realize that your data is symmetric, sometimes you have to look at the stats and sometimes you look at the picture. You're definitely going to be using the mean to describe the center. And remember, that is a typical value for your data set. And you're also going to use the standard deviation to describe the variation. That is the spread of the data. When your data is skewed, you're going to use the median. And the reason why you do that is because that mean is being pulled left or right. It's actually affecting it too much. So the median is going to be the best representative. And then you're going to use the IQR. Talked about that yesterday. Your IQR is the range of your middle 50%. So it's the Q3 minus the Q1. And you can get that from your 5-number summary using stats on Desmos. All right, so let's practice that skill. So what I want you to do is I want you to take a few seconds and I want you to type in all of this data. It's gonna take you a little bit of time. So be really careful and make sure that you have all of this data set in here. And when you have it, go ahead and start the video back again. All right, so I've got all 30 in Desmos and I'm gonna scoot it over just a little bit. Actually, what I need you to do is change this dot plot, change it to histogram. I'll show you why it's not a good idea to use a dot plot with this. So just watch me, you don't have to do this. So if I type dot plot of A, and if you can't see your data, all you have to do is click that, because this is what it looks like if you don't click that. It just kind of zoom fits it for you. This is really hard to see the data, and it looks to me like it might be skewed a little bit to the left, but I don't like that. I'm going to do a histogram instead. So you can type histogram if you want to, or if you forget the word, you can click on your little keypad here, go to functions. Statistics is where it gives you like information about the data, but if you wanted to look at the data, you want to look at visualizations. So you've got a box and whisker plot, the dot plot, which isn't the best thing, and then you have a histogram. Oops, make sure you do it on that second line. Try again. Okay. All right, so we have a little bit better look of our data here. It still looks like it's a little bit left skewed because I've got this high point over here, but then I got some data pulling it over to the left. I'm going to change that. See, right now it's got a bin width of 1. I'm going to change it to be 2. That makes the bars a little bit wider, includes a little bit more information. It looks a little bit better. So you see how the setting can change. Let's do 3. Let me zoom fit that. There we go. I think 3 is a little bit too big. I wouldn't go much more than that. So if I change it to 5, see, the bigger your bin width, the more data that you lose, but you can still see the general shape. So I'm going to leave it at 2. Okay, so now I know what that looks like. Let's go back over here to our notes. It says describe the shape. So according to that shape, I believe that that is going to be left skewed. And then it says which measures of center and variation. If it is skewed, what you need to do is use the median. So one more time, if it's skewed, that mean is getting pulled in a direction. It's greatly affected by that, you know, really small or really large data. So we're going to use the median, and then the variation, we're going to use the IQR. And remember, your IQR is Q3 minus Q1, okay? All right, so here we have a stem and leaf plot. In case you don't remember how to read a stem and leaf, you just look at the first number and then you pair it with a leaf. So that would be 50. This number would be 75. And then this number would be like 103, okay? Now, a stem and leaf plot is not like a histogram. So a histogram looks like this. A stem and leaf plot is more like this. You have to kind of turn it on its side. So if I turn it on its side and then I look at the middle of that data, it looks symmetric to me. Okay, so a stem and leaf plot, if it wasn't symmetric, it would have like a whole lot of numbers over here. So it would look something like that. You would have all these numbers. That would be like a left skew. So since it's symmetric, what would be the best measures of center and variation? That would be the mean, and you're going to use the standard deviation. Okay, we don't have a visual here, so what you have to do is you have to really think about it. So if I have a median, remember your median is at 17. So let's say I've got a median at 17. This is my median, and my mean is 10. So the mean is going to be over here on the left. Remember, if they're not approximately the same, it's going to be skewed. So I know it's going to be skewed, but which direction is it skewed? I don't know. All right, so you see how I put the 10 on the left? That means it's left skewed. What's happening is that you've got some numbers over here that's pulling your mean in that direction. So if your mean is less than your median, it's left skewed. If you look at these two numbers right here, you've got 65, this is your median, and then 65.4, that's practically the same number. So if they're approximately the same, then they are going to be symmetric. Okay, so just a really quick review. It's difficult to predict the measures of center and variability. So we either need to know the statistics, like your mean and your median, or you need to graph it. So a box plot is just going to be that is a dot plot. Lots of mistakes, sorry. Okay, so a dot plot consists of data points plotted on a graph. So it's going to look something like this. Like that. So that would be kind of like symmetric data. Now, a histogram is very much the same as this, except for you have categories, and it's going to look like a bar graph. It's not a bar graph, but it's going to look similar to that. And a box and whisker splits the data into quarters. So you got your little whiskers, and you got your data here in the middle, and they're all useful in different ways. And remember, that box is the middle 50%, and each little sector is 25% of the data. Okay, frequency. Which of these statements is true? So I want you to take a few seconds. I want you to read both of these questions, pause the video, answer them, and then unpause and see if you get it right. So in this first question, it's asking which statements are true, and you can have more than one answer. So let's see if this one's right. Most of the data is on the right. Well, if you look, most of your data is hanging out right here, and this is on the right side of the graph, so this is absolutely true. If most of the data is on the right, then this one is not true. The data is symmetric? No, this looks like a left skew to me, so that's out. The mean is less than the median, so I don't know it, but I do know that the mode is here because that's the highest point. If it's skewed, I know the median's going to be pulled a little bit to the left, but the mean is going to be pulled a lot to the left. So I'm going to estimate my mean over here, median. So yes, the mean is definitely going to be less than the median. And the data is left skewed. Absolutely it is. All right, so in this last question, it says the mean of the distribution. Obviously, don't try to find it because we don't, it's grouped into categories, so we can't. So the mean on a right skew, that is going to be pulled to the right. So is your mean going to be close to the median? No. It's going to be greater than the median? Absolutely. So your median's going to be about right here, and your mean's going to be pulled to the right. I should put mean and median. Clearly less than the median? Absolutely not. That would only be if that was a left skew. Cannot be determined? Yeah, you can determine the relationship between the two. And that is it for this lesson. So here are your practice questions, and let me know if you have any questions.